Yeah, good afternoon all. Now let us take the question number 3. What are collisions? Explain the possible types of collisions. Develop the theory of one-dimensional elastic collision. So this is one of the very important question. If two questions which we already studied, okay, if you are not going to get it on the paper, then you will see this kind of question. But here this question is a bit extensive one. Why? Because there are a lot of things he is asking. First one is he is asking about definition. What is the meaning of collision? For that you are going to get 1 mark. And then Sri explain the possible types of collisions. That means how many types of collisions are there? Okay, if you write how many types, there are 2 types actually, you will get 1 mark. If you explain them, then you will get 1 more mark. Most of the students here, they simply write the types of collisions, but they miss to explain about them. So you should not do such kind of thing because you are going to lose 1 more mark. So 3 marks. And then what he is asking, develop the theory of one-dimensional elastic collision. That means again, based on the dimensions, you have to one-dimensional collisions are there, two-dimensional, maybe three-dimensional. But in our syllabus, we have one-dimensional elastic collision. So it is better to explain what is one-dimensional elastic collision, and then we have to develop the theory. That means what we are going to do in this question, while developing one-dimensional elastic collision, there are particular structure. What is that particular structure? First, we have to consider that these are elastic collisions only. In elastic collision, generally what happens? Momentum and kinetic energy conserves. So you have to draw those two statements here. One is regarding momentum and another one is regarding kinetic energy. Okay, and then you will come to a particular point where the relative velocity of approach is equals to relative velocity of separation. Till this point, if he is asking, it is for 4 marks. Okay, there is one more question for us. But after that, what we do means, we are going to find out these final velocities. We are going to find out these final velocities. Then our question completes. So, here you are going to get 3 marks for the definitions, and developing this theory you will get 5 marks or maybe sometimes 4 marks only if he is specifically mentioning marks for one-dimensional definition also. So in this way we can distribute the marks for this question, right? So now let us see what are collisions first, and then we will move towards different types and all different things slowly and steadily. So what are collisions? Collision means what? Collision means what? Definition of collisions. See what happens generally. Suppose there are two bodies which are moving in a particular direction. Okay, if the first body's velocity is u1, second body's velocity is u2, and u1 is greater than u2. That means, say for example, it is moving with 20 meter per second and it is moving with 8 meter per second. After some time, what happens? This first object, whatever we are calling it A and B, A crosses somewhere the B. So while crossing, there may be a chance of collision, right? So they will collide. So what happens in particular whenever they are colliding with each other? After collision, what happens? Again, there is a chance of moving separately or sometimes together. Okay, so in collision, what is happening? A strong interaction is happening. Interaction means they are colliding with each other. Okay, over a short period of time. You might have seen in our real life example, okay, where an accident happens. A car is moving on it, and behind that a particular vehicle, say lorry type, coming, and they are colliding. How much time they will collide or stick together? Maybe a fraction of seconds. But what happens after that? Again they move separately. In the same way, here also collision means a strong interaction between the two bodies, or a short period of time. In that short period of time, what is going to happen? The momentum is redistributed or exchanged. That we call it as collision. Okay, got it? So now what we are writing? A strong interaction between the two objects how much time? Very short period. For a short period of time, where momentum is redistributed. What it is? Redistributed or exchanged, you can write. So a strong interaction between the two objects over a short period of time. Okay, where actually it is not when, where momentum is redistributed. Okay, if you are writing this definition, you will get 1 mark. How many marks you are going to get? 1 mark you are going to get. So this is what? Collision. Note it down. See, I am going to explain about conservation of momentum and conservation of energy for your understanding purpose. So while writing the notes, for sake of examination, while writing, you have to keep in mind that you have to write only definition and then types and then developing theory. Right? Let us see how it goes. Now, okay, types of collisions. Types of collisions. Types of collisions. Actually, there are two types of collisions. One is elastic collision and second one is inelastic collision. Inelastic collision. So what is elastic collision and what is inelastic collision? See, if you write this much only, you will get 1 mark. But if you explain what is inelastic and what is elastic, then you will get full marks, 2 marks. So in elastic collisions means the collisions in which, simple, the collisions in which both momentum and kinetic energy is conserved. The collisions in which both momentum and kinetic energy is conserved. Example, you can write if you are able to. Okay, simple collisions between gas molecules. Collisions between gas molecules. Okay, and 1 second. Here it is very high humidity. Out of sweat is coming. Okay, inelastic collision. So the collisions in which only momentum is conserved. Momentum is conserved. The collision in which only momentum is conserved. That means here kinetic energy is not conserving. I think you already know what is conserve. The meaning of conservation already we studied in our second question. Conservation means being constant. Okay, so in inelastic collision, the collision in which only momentum is conserved. Example, okay, hitting a ball with bat. Whatever you can give. Hitting the ball with bat. Here only momentum is conserved, but not the kinetic energy. Okay, if you write this much, you will get 2 marks here. One is for types and one is for explanation and giving examples. If you are able to give examples, fine. If not, at least you have to mention what is elastic and what is inelastic collision. Okay, I think you understood. Now let us move towards development of this part. Develop the theory of one-dimensional elastic collision. Okay. Let me explain. If you want, I am going to explain what is momentum conservation and what is kinetic energy conservation. But the video may be extensive for another 5 minutes because that is what happens. But there is no need to write those things. Okay, let us discuss that part as well. So conservation of momentum, let us see what happens. So momentum conservation, I am talking about momentum conservation. See, momentum conservation means, say for example, there is a system in which we have 2 objects, A and B. Okay, together these 2 are called system. In the system we have 2 objects A and B. Now let us consider its mass is m1 and its mass is m2. And its velocity is u1, initial velocity, and its velocity is u2. Now what is momentum of first body and what is momentum of second body? From the definition of momentum, you know that the product of mass and velocity is called as momentum. So momentum is generally denoted with P. P is equals to m into V. That means here simply the momentum of first body is m1 u1, second body is m2 u2, right? Now they are moving. As I said earlier, u1 is greater than u2. What happens after some time? These 2 bodies will collide with each other. That means they are participating in the collision. We know that what happens when the 2 bodies are participating in a collision. There is an exchange of momentum and as well as there is an exchange of kinetic energy. Let us see first momentum. So the momentum is going to be exchanged. After collision, what happens? The bodies will move separately. Here mass is going to be having same because mass is not going to change. But their velocities will change. Therefore, initial velocity of first object is u1. Now final velocity is v1. Here v2. Now the momentum here is m1 v1, m2 v2 because the product of mass and velocity gives you momentum. Right. So here this is collision part. So this is what before collision thing. This is what after collision. Before collision and after. What we are saying is the system's momentum, whatever it is there before collision, is must be equal to after collision. For example, okay, I am taking some numerical values here. Say consider m1 is equals to 5 kg and u1 is equals to 8 meter per second. Then momentum is how much? 5 into 8, 40 meter per second. 40 kg meter per second because it is momentum kg meter per second. Here second body's moment mass is 3 kgs, okay, and velocity is 10 meter per second. Then what happens? See, 3 into 10, this is 30 kg meter per second. Now total momentum is how much? 40 plus 30, that is around 70 kg meter per second. So before collision, the system is having 70 kg meter per second, the momentum. Now what we are saying, momentum is conserved. That means After collision also, the system is going to have the same amount of momentum, 70 kg meter per second only. But what happens? The momentum is redistributed or exchanged between the objects. Okay. So how it is going to redistribute? We know that mass is not going to change. There is no change in the mass. So obviously, say for example, the final velocity of first body is 2 meter per second, and here 5 into 2, how much? 10 kg meter per second. The momentum of first body is now changed from 40 to 10 kg meter per second. Whereas here we to consider it is 20 meter per second. Now what happens is 3 into 20, that is 60 kg meter per second. If you add these two, again you are getting how much? 70. That means before collision, whatever the momentum it has, the system, after collision also it is going to have the same amount. But the important thing here is the momentum is redistributed. So in collisions, what happens? The momentum redistributed between the objects. Okay, so this is the concept of momentum conservation. As I said, there is no need to write all these things, but for the sake of understanding, you have to know this, right? In the same way, kinetic energy conservation. I think you got it. Okay, before collision, the system momentum is 70. In the system, we have two objects. For first one is 40, second one is 30. And after collision also, we have two bodies, but their momentum is slightly changed. For first one's momentum changed from 40 to 10, and second 30 to 60. But overall, the momentum is same. Now let us understand kinetic energy conservation as well. Then we will try to develop our concept. Okay. These are not required to write in examination. Just you write that much enough. Okay. Conservation of kinetic energy. I generally write kinetic energy as Ke. So now consider there is an object A and object B. Together these two form a system. If these two are colliding with each other and then separately moving after collision, this is after collision. Okay, this is before collision. Say for example, A is having an energy of 10 joules. B is having energy of some 15 joules. Together how much? 10 plus 15 means 25 joules of energy they have. 25 joules of energy they have as a system. Now these two are participating in the collision. After collision, what is happening? The system's total kinetic energy, whatever we have, 25 joules, is not going to change. But what is going to change? The kinetic energy will be redistributed or exchanged between the objects or bodies. So now, first body may be having 12 joules of energy. Second body may be having 13 joules of energy. Okay. Now see what is happening. 12 plus 13, 25 you are getting. But earlier A has 10, now it has 12. B has 15, now it has 13. That means the exchange of kinetic energy happened. So if this happens, okay, we call it as conservation of kinetic energy. So in elastic collision means what? Both the momentum and kinetic energy both are conserved. Whereas in inelastic collision, only momentum is conserved. Now what is one-dimensional collision? One-dimensional collision. So in one-dimensional collisions, what happens means, as the bodies are moving along with a particular straight line, the direction of velocity is, okay, straight line before and after collisions. Okay, so what we write, the collisions in which the direction of velocity is straight line before and after collisions. Before and after collisions. Okay, such collisions are called one-dimensional collisions. Okay, the collision in which the direction of velocity is straight line before and after collisions, such collisions are called one-dimensional collisions. Okay, so for this also you may get 1 mark. Okay, so out of 8 marks we have got 4 marks till now, right? Definition of collision, types and explanation of collisions, and then one-dimensional. Now let us develop the one-dimensional collision theory. This is what more important for us. From here we have to find out the final velocities of the two bodies v1 and v2. So according to law of conservation of momentum, okay, according to law of conservation of momentum, according to law of conservation of momentum, okay, you might you can write like this also. Consider two objects m1 and m2, their velocities are u1 and u2, okay, and u1 is greater than u2. After some time they are colliding with each other, and then their final velocities are v1 and v2. Like that you have to write. And according to the law of conservation of momentum, what we know, momentum before collision is equals to what after collision? Momentum before collision is equal to after momentum after collision. So, or other words, according to law of conservation of momentum and RCC, okay, you just write the statement directly, no issue at all. Okay, so m1 u1 plus m2 u2 is equals to, this is momentum before collision, okay, of the system, right? m1 v1 plus m2 v2. Now what you do is simply bring the terms one side. m1 u1 minus m1 v1, m2 v2 minus m2 u2. Right. And according to law of conservation of kinetic energy, okay, what we know, kinetic energy formula we know, half m1 u1 square plus half m2 u2 square is equals to half m1 v1 square plus half m2 v2 square. Okay, in this, if you take common, half will come out, but in all the four terms we have common thing, that is half. So simply you can cancel it. Okay, now you write m1 u1 square plus m2 u2 square is equals to m1 v1 square plus m2 v2 square. The same thing what we did in first case, here also we do the same thing. m1 u1 square, bring ones one side, m1 v1 square is equals to m2 v2 square minus m2 u2 square. Now take the common term out, m1 u1 square minus v1 square is equals to, here also v2 square minus u2 square. Here you can extend one more line. Okay. See, m1 u1, bring v1 this side, m1 v1, m2 v2 minus m2 u2. Take the common term out, u1. Okay. m2 here also. u2. Now give this as equation 1 and now give this as equation 2. Right. Now what you need to do, you have to divide equation 2 by 1. 2 by 1. So what is 2 here? See, m1. See here, a square minus b square. In mathematics we have one formula, a square minus b square is equals to a plus b into a minus b. Right, this is the formula. In the same way we can write this as m1 into u1 minus v1 into u1 plus v1, okay, by 1. By 1 means left side of the 1 is what? m1 u1 minus v1 is equals to m2, okay, v2 minus u2 v2 plus u2 by m2 v2 minus u2. Okay, so here m1 term cancels, m2 cancels, u1 minus v1 cancels. So remaining term is what? u1 plus v1 is equals to v2 plus u2. Now bring the terms u one side and v's one side. So what happens? u1 minus u2 is equals to v2 minus v1. Okay, this is equation 3. This is one of the very important equation. This is generally called as relative velocity of approach is equals to relative velocity of separation. Okay, there is one question, 4 marks question, show that relative velocity of approach is equals to relative velocity of separation. If that question comes, you have to write till this point from here. You will get 4 marks for this. Right. So u1 minus u2, what it is? Relative velocity of approach. Approach into the ground is equals to what? Relative velocity of separation. Okay. So this one particular equation is very important to find out the v1 and v2 values. Okay. Okay. I think till this point you might have you understood. I hope. See, we are not doing any new thing. Simply we have taken according to the law of conservation of momentum. We are writing momentum before the momentum of the system before collision is equals to after collision. So m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. What I am doing here, bringing one terms one side, two terms other side. That means m1 u1 minus m1 v1 is equals to m2 v2 minus m2 u2. I am taking out common term. In these two, common term is m1. So I am keeping it out and writing u1 minus v1. Here also common term is m2 and v2 minus u2. Now I am labeling it as equation number 1. Now I am applying law of conservation of kinetic energy. So according to the kinetic energy formula, we know half mv square. Here initial velocity is u1, so I am writing it as u1 for second object, and afterwards collision also I am writing, I am striking off the common term half here, and then again I am writing the remaining terms, and then I am taking one terms one side, two terms other side and taking common. And after this I am labeling it as equation number 2. The important point here is you have to divide the equation 2 by 1. This is generally we forget sometimes. Okay, right. While writing here as u1 square minus v1 square is in the form of a square minus b square, I am applying that formula as a plus b into a minus. So u1 minus v1 into u1 plus v1. Here v2 minus u2 into v2 plus u2. Minus terms will get cancelled. The remaining part is u1 plus v1 is equals to v2 plus u2. Therefore, u1 minus u2 is equals to v2 minus v1. This is the equation number 3. Okay. Now let us find out velocity v1 and v2. Okay, to derive that, this equation is must. We know that equation is u1 minus u2 is equals to v2 minus v1, right? From this, what I will do is I will write v2. That means I have to bring this minus v1 towards this side. What happens this one? u1 minus u2 minus v1 comes this side, means plus v1. So v2 is equals to u1 minus u2 plus v1, right? Now substitute this value in the equation 1. Okay, in which equation we have taken from the law of conservation of energy, what we have written m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. In this equation, substitute here this value, v2 value. So for that sake, what I am doing, m1 u1 plus m2 u2 is equals to m1 v1 plus m2. v2 means what? u1 minus u2 plus v1. Now simply expand it, m2 u1 minus m2 u2 plus m2 v1, right? Okay, now what you need to do, take out the m1 u1 m2 u2, these one side and use one side. Let us see how it goes. m1 u1 plus m2 u2, because we have to find out the value of v1, so we have to keep it one side. Now minus, this term I am bringing this side, so minus m2 u1, this minus m2 u2 comes this side, m2 u2. Okay, remaining terms are this one and this one. Here v1 is common, so okay, m1 plus m2 of v1 I can write. See here, m1 v1 plus m2 v1. ఎలా ఉంటుంది? m1 v1 plus m2 v1. సో v1 కామన్ తీసాను అనుకోండి, ఏమవుతుంది? ఇలా అవుతుంది. సో దట్ ఈస్ వాట్ ఐ యామ్ రైటింగ్. ఓకే, గాట్ ఇట్? Right. Now you have to find out, see here, m1 u1 and what other things we have? m2 u1. u1 term is common. Okay, m2 u2, m2 u2, 2 m2 u2. So from here I am taking out common u1. So m1 minus m2 of u1 plus m2 u2, m2 u2, 2 m2 u2 is equals to m1 plus m2 of v1. So you need v1, so bring that m1 plus m2 term to this side. m1 minus m2 u1 plus 2 m2 u2 by complete m1 plus m2. So therefore v1 is equals to, separate it, m1 minus m2 u1 by m1 plus m2 plus 2m2 u2 by m1 plus. This is how you will find out the value of v1. So whenever you are taking here v2, keep in mind, okay, you are writing the value of v2 in this equation, then you are getting v1. If you want v2, what you need to do? You have to find out v1 here, right? Got it? Simple terms, just you have to substitute these values, expand it, simplify it, you will get v1. Okay, now let us move towards v2, finding of v2. Okay, right, I am removing all these things. You can pause and note it down. Okay, no worries. Now I need what here? v1. So to write v1, see how it goes. You need v1 is equals to, so bring this v1 this side, or otherwise simply what you do means u1 minus u2 plus v1 is equals to v2. This is what you got now. Now take out these things that side. v1 is equals to v2 minus u1 plus u2. Okay, You have taken this side, okay, and then you have to shift that side. You need V1, right? Or otherwise, you can do like this as well. U1 minus U2, bring this minus V2. Now what happens? This is minus V1, right? Multiply with minus both sides, right? Then what happens? Minus V1 minus into minus, plus U2 minus into minus, plus V2 plus V1. See, that is what we got. V2 plus U2 minus V1. So either way you can get, that is not a problem. Based on your convenience, you can go, right? Next, one second. Okay, again same. Now substitute this value in m1 u1 plus m2 u2, law of conservation of momentum, m1 v1 plus m2 v2. Okay, so m1 u1 plus m2 u2 is equals to m1. Instead of v1, we are writing what? Plus m2. I think you know right now. You just expand it. That's enough. m1 u1 plus m2 u2, m1 v2 minus m1 u1. See, I am multiplying m1 into v2, m1 into u1, plus into plus plus m1 v2 plus m2 v2. Same thing, use one side. So m1 u1, okay, here minus m1 u1 is there. If it comes this side, plus m1 u1 plus m2 u2 we have here, this one, and anything that we have here, v2 u2 kada, this is u2, this is u2, this is u2. So if it comes this side, m1 u2, so remaining terms are what are there? m1 v2 plus m2 v2. Okay, I am writing clearly this one, m1 u2. Okay, now m1 u1, m1 u1, 2 m1 u1, right? Here common term what we have u2. So here what happens? m2 minus m1 of u2. Here common term is v2, so m1 plus m2 of v2. Right. Now bring this towards this side. You need v2, so what you need to do? 2 m1 u1 plus m2 minus m1 u2 by m1 plus m2, that is equals to v2. Therefore v2 is equals to, separate it, denominator you are simply separating, nothing is going to happen, m2 minus m1 u2 by m1 plus m2. So this is the final velocity. Okay, if you are solving and getting these equations v1 and v2, which means you have completed the concept of developing one-dimensional elastic collision. This is how it is. So it is very simple. There is no need to worry about lot of calculation, lot of writing going on, but there is no need to worry. The thing here is you have to keep in mind while developing, you are using law of conservation of momentum and law of conservation of kinetic energy. So from first equation, law of conservation of momentum, you will write m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2, and then from the law of conservation of energy, then go what you do, 2 by 1, equation 2 by equation 1. From there you will get relative velocity of approach is equals to relative velocity of separation. If you do this much thing correct, then automatically you can calculate v1 and v2, because once you know this line, this equation, okay, you are just getting the values of v2, okay, and keeping in the first equation. Wherever V2 is there, you have to substitute, separate it, and then you will get V1 value. In the same way, if you are keeping here V1, you are going to get V2. Okay, so this is how this concept goes on. Practice it 1 or 2 times, or maybe how many times you require, but thoroughly understand the concept properly. Okay, practice and then submit me. Thank you very much.